MBA633 instructional video prepared by Professor Ahmed Dada, School of Management, George Mason University. In this clip, we'll continue our discussion of probability and introduce the concept of events and how to compute the probabilities of events and combinations of events. So as an example, let's pick the following simple experiment. Pick any one card from a standard card deck. Now, what are the possible outcomes? And one possible outcome could be it's a jack of clubs. Another possible outcome could be a king of diamonds, and so forth. So you remember the definition of sample space that we had stated earlier. Sample space is the set of all possible outcomes. So in this case, once you have a standard card deck, the sample space consists of 52 possible outcomes. Since there are 52 cards in a standard deck. So there are 52 possible outcomes in the sample space. Now consider the following, what we call an event. Let's say we define the event in the following way. The card picked is a red card and we represent this event by the letter R. You can see in the sample space I've represented it by this irregular shaped shape in red, and this event R simply consists of a collection of outcomes that meets a certain criterion. In other words, the criterion is that the card is red. Clearly there are 26 such outcomes. There are 26 such outcomes, right? So therefore the probability of this event, so the probability of R is simply 26 divided by 52, which would be 0.5. Okay, now take the second event that we have defined in the following way. The card picked is a king, which I have drawn in this picture in green. So this particular outcome again, this particular event, an event being a collection of outcomes that meets a certain criterion. In this case, the criterion is that the card should be king. This particular event clearly consists of 4 outcomes. Okay, hence the probability of king is simply 4 divided by 52. Okay, is equal to 1 divided by 13. So that's the probability of a king. So now we have these two particular events R and K. Let's define a combination of these two events. So I want to know what is the probability that this one card that is picked is either a red, is a red and is also a king. Okay. Now if we draw these two circles, shapes again, R representing the set of outcomes that match the event R, namely the card is a red card, and the green shape representing the event that the card picked is king. This particular event that the card picked is red and is a king is clearly represented by the area in the middle. And as we all know from our knowledge of cards, this particular intersection of the two events is represented, this event is represented as R intersection K. So and is an intersection and represents an intersection. The card picked is a red and a king is represented by R intersection K. This consists of all outcomes that are this consists of all outcomes that are both in R and in K. Hence it's the shaded portion in the middle. And we know that this consists of exactly 2 outcomes. So the probability of this event, this combination of events rather, the probability that the card picked is red and is a king is simply 2 divided by 52. Okay. Now let's think of another combination of events. We say what is the probability that the card picked is a red or a king. Now this is what's called an inclusive OR. So what we are saying is that the card picked is either a red or a king or both. So it could be king of hearts or king of diamonds, for example. Okay. In terms of graphical representation, this event is represented by the shaded area that consists of the union of these two. Okay, and in set theory terms, this event that the card picked is red or a king is represented as R union K, red union king. Okay, now the probability of this event. Now, if you want to know how many outcomes there are in R union K, clearly it is the number of outcomes in R plus the number of outcomes in K minus the outcomes in the middle, because once we add R and K, we have double counted the segment in the middle. So the probability of R union K is simply the probability of R plus the probability of K minus the probability of R intersection K. Okay, so this probability, if I now write it down in the open space to the right, it would simply be 26 divided by 52 plus 4 divided by 52 minus 2 divided by 52. That would be the probability of R union K. Okay, that the card picked is either red or a king. Another event, what is the likelihood that the card picked is not a king? The way we represent this statement is not king, so that symbol that you see preceding the K is a not symbol, and I want to know the probability of not king. So again, this is an event. Remember, the sample space is the collection of all events. We know that there are 4 outcomes in the event K. Okay, therefore we know that there are 52 minus 4 outcomes in the event not K. Therefore the probability of not K is simply 52 minus 4. That's the number of outcomes in the event not K, and we divide that by 52 because there are 52 possible outcomes in the sample space. Alright, now a couple more combinations of events. So let's look at the following event defined as follows: that the card picked is red but it's not a king. In terms of shading the area that we need, clearly the set of outcomes that we're talking about is this shaded portion. So this is the set of all outcomes that are in R but not in K, correct? So how do we compute this? I know that there are 26 outcomes in R, and I know that there are 2 outcomes in the middle. Okay, so the shaded portion is simply 26 minus 2, which is 24 outcomes. Okay, therefore the probability of R minus K, so the card picked is a red but is not a king, is simply 24 divided by 52. That's the set, since 52 is the number of outcomes in the sample space. Similarly, if we ask what is the likelihood that the card picked is a king but is not a red, then the set of outcomes that we are thinking about is the shaded portion over here. Okay, and I know that there are 4 outcomes in the shaded portion called K totally, and like before there are 2 outcomes in the intersection, Therefore, the portion shaded in yellow has 4 minus 2 outcomes. So the probability of K minus R, that is, the likelihood that the card picked is a king but is not red, is simply 2 divided by 52. So in terms of combinations of events, what we have seen is union, intersection, difference. These are different combinations, and complement. Okay, so this is the complement of K. So we've seen what we mean by an event, what are the different types of combinations of events, and how one goes about computing the probabilities of events. All through this discussion, notice how critical it is to know what the sample space is and how many outcomes there are in the sample space. After all, events are combinations of outcomes which are simply subsets of the sample space. So these are some of the basic rules that one uses in computing the probabilities of events and combinations of events.